We're going to look into the process to machine a simple part using various software and equipment. First off, the phase converter is started by pushing the start button, generating three-phase power from single phase. The next step is to turn on the main power switch on the back of the mill. You can watch the control screen as it goes through its boot sequence. When this completes, we'll hear a loud clunk when the main power contactor closes. Now we're ready to home the machine. Push the mode button, then 0, then R for reference. First, the X and Y axes must be referenced by toggling the X and Y jog switches. When referencing, the feeds can be controlled, but will not be very fast to avoid overrunning the limits. The Y reference won't take very long, but it's good practice to park the table close to the home position to avoid having to wait for it to travel a long way in X. Once X and Y have referenced, the Z switch will start the Z reference move. When all axes are referenced, the screen will stop flashing. To jog away from the axis limits, select mode 0 again and then 2 for rapid. Then each of the axes can be jogged to move the tool closer to where its cutter path is going to begin. The next step is to hit mode select and then 5 to go to setup mode. We can see that the control is set for metric. To change to inches, SM0 would be selected instead. Next, we'll set the machine to receive cutter path information by hitting mode select and then 8 for transmit receive. Key in S1 for serial port 1 and then enter. Next, we'll start the spindle. Hit mode select and then 9 twice for manual data input or MDI. Key in M03 for clockwise spindle rotation, S1000 for 1000 RPM, and then push the green cycle start button. One quirk of this machine is that it will always show a fault and instruct you to change the gear range. Just clear the fault and repeat the previous spindle start steps. Usually it will work on the second time, but sometimes needs a third try. Once the spindle starts, this function will be fine until the next time that it is powered up. We use an edge finder to determine the center of our gauge pin for this particular setup, and then save this position as an E offset. Here's a stack of parts that will be cut. The radius is laid out since they were going to be cut manually. Each one will be cut alike using the holes already drilled to locate the parts in the machine. A very simple design was created in Millwrite. The black line shows the part outline and the blue line is the center of the cutter path. Notice the lead in and lead out radii to enter and exit the path smoothly. Since the part will be hanging out of the vise, we'll take it easy with 3 passes. The cutter path can be simulated to show that everything looks okay before sending the program to the machine. The path is post-processed and then sent to the computer, which is directly connected to the machine control using extreme DNC software. This is old software, so we'll select the tree, this machine, and then click the pick up the phone icon to connect. Remember desk phones? Next, we'll find the program to get ready to drip feed it to the machine control. The first part is located over the home pin and then gripped in the vise. To get ready to receive the program, hit Mode Select, then 1 for Auto. Hit Reset to clear the memory, and then the green Cycle Start button. With the control ready and the program selected, click Send to transmit the file to the control. That's all that's left. Now sit back and watch the chips fly. For each remaining part, just load device, select mode 1 on the control, hit cycle start button, and then click send again on the DNC computer. Here are half the pieces ready to ship. Thanks for watching. You can see a lot more regarding this particular project at this site.